In this problem, we are asked to prove the inequality 1 to the power n is greater than 1 plus na. And the proof is asked to be done by induction. I mean, we can do it using the binomial formula, but here this exercise is more about whether someone knows how to use the induction argument. Okay? So of course, if you take n equals 0, the left-hand side of the inequality gives us 1, and if you take n equals 0 to the right-hand side, it will give you 1. So they are equal for n equals 0 as well as for n equal 1. That's why they asked for the strict inequality to start at n equal 2. So what we'll start first is to check that is the case for n equal 2. So first, we check the inequality is true for n equals 2. So we have 1 plus a squared equal 1 plus 2a plus a squared. Since a is positive, non-equal to 0, then 1 plus 2a plus a squared is going to be bigger than 1 plus 2a. In other words, we have 1 plus a squared is bigger than 1 plus 2a. So the inequality is true for n equals 2. Assume that 1 plus a to the power n is greater than 1 plus na. And we need to prove, let us prove that 1 plus a to the power n plus 1 is greater than 1 plus n plus 1 times a. First, note that 1 plus a to the power n plus 1 is equal to 1 plus a to the power n times 1 plus a. Since a is positive, 1 plus a is positive, and we can use now the induction property, and we get 1 plus a n plus 1 equal 1 plus a, as we said, 1 plus a. And now we use the induction assumption, which is that 1 plus a to the power n is bigger than 1 plus na. And since a is positive, 1 plus a is positive, and therefore we can multiply by 1 plus a and preserve the order of the inequality. So now, what is this 1 plus na times 1 plus a? That is 1 plus na plus a plus n a squared, which is equal to 1 plus n plus 1 times a plus n times a squared. Since a is positive and n is greater than 2, this will be strictly bigger than 1 plus n plus 1 times a, which means that 1 plus a to the power n plus 1 is bigger strictly than 1 plus n plus 1 times a. In other words, we proved the inequality for n plus 1. So now, by induction, the inequality is true for any n greater than 2.